Quantification is one of the objective of analytical experiment, and there are various ways to meet this objective. It has been observed and found that the external standard is widely used for the quantification, and this is one of the most accurate technique amongst the others. Now, when we understand and realize that there is a great need to have the external standard during the quantification, the next obvious question will be how one can define the concentration of standard solution. And as a part of this video, I am going to explain you how one can decide on the concentration of standard solution during a residual solvent analysis. And this knowledge you can also relate with the defining the concentration for standard during related substances analysis too. So how we are going to understand this entire process, and it is 8-step process, and you can see this all 8 steps on the screen. The first step is what is the limit of residual solvent. The step number 2, what is the sample preparation. Step number 3, what is the content of methanol at the limit level in milligram present in the sample. So methanol is the example I have taken as a residual solvent. The step number 4, what is the concentration of methanol or a residual solvent at the limit level in milligram per ml, which is present in the given sample quantity. Then step number 5, understand the concentration for the standard. Step number 6, define the standard solution preparation. Step number 7, define the calculation formula. And step number 8, simplify the calculation formula. Now this video could be little lengthy, but my intention is to explain you the entire process very step by step so that you will get the complete clarity. So in case if you observe the video, watch the video until the end, I promise you, you will get the 100% clarity on defining the standard concentration. Hello and welcome. This is Bhaskar Napte from Pharma Growth Hub. I have helped more than 700 pharma professionals to get absolute clarity on various technical aspects, and the one that we are discussing right now, but with the help of a proven system. So if you are struggling with technical aspects, or if you are struggling with your career growth, not able to understand how to identify the new job opportunities, and would like to unleash your true potential, join the Pharma Growth Hub today. Now, to know more about the services of the Pharma Growth Hub, send me a WhatsApp message as interested on the number shown on the screen. Let us now begin with the step number 1, and that is what is the limit of a residual solvent. So let me put the step number over here. So what is the solvent that we are going to quantify? Let us say it is methanol with limit of 3000 ppm. We all know the limit of methanol is 3000 ppm according to the ICH guideline Q3C. The next important point is the step number 2, and that is what is the sample preparation process. So I'm just going to paste the step number 2 over here now. So how the sample will be prepared, and let us say the sample preparation process is dilute 200 milligram of sample to 50 ml, right? So this is our sample preparation procedure. We completed step number 1 and step number 2. Let us now understand what is the requirement for the step number 3. Let me copy the step number 3 and let me put the step number 3 over here now. So we need to understand what is the content of methanol at the limit level in milligram present in the sample. We know the limit of methanol, how much it is? The limit is 3000 ppm, or the limit for methanol is 3000 ppm. Now can I write below statement? Please confirm. 3000 milligram of methanol in 1 kg of sample. Is that the same one? Because we know that 1 ppm is nothing but 1 milligram per kg. So the 3000 ppm is going to be 3000 milligram present in a 1 kg of the sample. I hope you are with me so far. Now what is the content of methanol at the limit level? And the limit level is how much? 3000 milligram of methanol present into 1 kg of the sample. Now as my sample measurement is in milligram, I need to convert this 1 kg into a milligram. So how I can convert this 1 kg into a milligram? And let me show over here. So this 1 kg can be a 1000 gram, right? And this 1000 gram, if I multiply this 1000 gram by 1000, can I say now this is the weight in terms of milligram? So how much it is? 1000 into 1000. I will just keep this way. I will not convert into the figure, but I will just keep 1000 into 1000 milligram of the sample. Now, am I taking 1 kg of the sample for the analytical experiment? Absolutely not. So how much sample I am taking? I am only taking 2000 milligram of the sample. So I need to understand if 1000 into 1000 means how much? 10 lakhs milligram of the sample contain 3000 milligram of the methanol. How much will be methanol present in 200 milligram of the sample? I will say it is X milligram of methanol will present into a 200 milligram of sample, right? So I will also put the equal sign over here, right? So we got two different equations. The first one is 3000 milligram of methanol is present into a 10 lakh milligram of the sample. So X milligram of methanol will present into 200 milligram of the sample. So will I be able to calculate the X milligram of methanol right now? And here is the way. So X milligram of the methanol will be just do the cross multiplication and it will be 3000 into 200, yes, divided by 1000 into 1000. Okay, so I need to put one more zero over here. So let me take a calculator now. So how much is what is the calculation I need to do? That is 3000 into 200 divided by 1000 divided by one more 1000. So how much I got? I got 0.6 milligram. So the 0.6 milligram, this means 0.6 milligram of methanol will present in 200 mg of the sample when I talk about 3000 ppm. I hope you are clear up to this very important step. Now this step is very important and I will explain you why this step is so important. So we calculated the content of methanol at the limit level in milligram. Look at 0.6 milligram present in the actual sample, that is 200 milligram. So let me explain you what is the next step now, and that is the step number 4. And this step says that we need to now calculate the concentration of methanol at the limit level in milligram per ml present in the sample. So let me put the step number 4 over here now. So what is the content of methanol in mg first? We know this is the content of methanol in mg in 200 ml, 200 mg of the sample. So this 200 mg of the sample is getting diluted to how much ml? Yes, this 200 milligram of the sample is getting diluted to how much ml? And for that, you need to know the sample preparation procedure. That is step number 2, which says that the 200 milligram of the sample will get diluted to 50 ml. 50, right? So 50 is the answer. I know that the sample will get diluted to 50 ml. So in case if now what is the content of methanol at the limit level in 200 mg of the sample? Look at here the zero point 0.6 mg, right? So can I say that if the sample is getting diluted to 50 ml and if the sample contain 0.6 milligram of the methanol, now tell me at what volume this 0.6 mg of methanol will also get diluted? And it will get diluted to 50 ml. So can I say that the concentration of methanol at limit level, right, in mg per ml is equal to 0.6 mg, 0.6 mg diluted to 50 ml. And if I further simplify this equation, how much it is? So let us bring the calculator one more time. So 0.6 mg, okay, let me also show you from where I am taking the figures. 0.6 mg diluted to 50 ml, it becomes 0.012 mg per ml. It becomes 0.012 mg per ml. So we got the concentration of methanol. We got the concentration of methanol at the limit level. At the limit level, and that is how much? 0.012 mg per ml. So the purpose of step number 4 is now completed. We got the concentration of methanol in mg per ml. What is the step number 5? The step number 5 says understand the standard concentration. Okay, now this is very crucial step. This is very crucial step, and let me paste over here. Understand the standard concentration. So ideally, what should be the standard concentration according to you? The standard concentration should be the concentration of methanol present in a sample at the limit level. Yes or no? And what is the concentration of methanol at the limit level present in a sample? That is 0.012 mg per ml. So can I say that? Can I say that the standard concentration should be 0.012 mg per ml? Right? The standard concentration should be 0.012 mg per ml. How I am going to prepare that is the next step. But I must first understand what is the concentration of standard in mg per ml. I hope you understand this step. This step is very important because we are now understood the concentration of standard or concentration of methanol standard with respect to 3000 ppm. Right? Now the step number uh, 6. The step number 6 is define the standard solution preparation. What is the step number 6? The step number 6 is now defining the standard solution preparation. So how you are going to prepare 0.012 mg per ml of the methanol? So let me take the required concentration for preparation is the 0.012 mg per ml. So I will say weigh 120 mg of methanol and dilute to 100 ml, right? Further, dilute 1 ml of resultant solution to 100 ml. So how much is the concentration I am getting? Let me confirm the concentration whether I am able to achieve 0.012 mg per ml or not. So I have taken 120 mg of methanol diluted to 100 ml You may not be able to see the dilution details, but further the 1 ml is diluted 200 ml. And how much is the concentration in mg per ml now? 0.012. And that is what we are looking for. So we actually got 0.012 mg per ml concentration of methanol. So we are able to defining the standard preparation now. Weigh 120 mg of methanol, dilute it to 100 ml, then further dilute 1 ml of the standard stock solution to 100 ml, becomes 0.012 mg per ml. So step number 6 is also completed. Let us now go back to the step number 7. And what step number 7 says? Now define the calculation formula. Right? Define the calculation formula. So let us understand the calculation formula with the help of step number 7. As you have prepared standard solution, sample solutions, you are going to analyze both of them. And as a part of your result, you find that you get the peak area A or the response A for the standard solution. You may be using, let us say, gas chromatography procedure, and you got the response A for the standard solution. So what is the concentration of standard solution, by the way? Concentration of methanol in the standard solution, and it is 0.012 milligram per ml of methanol. I hope you remember this term, right? The second is what? You analyze the sample solution also, and you found the response B. Response B, the peak area B for the standard, for the sample. So you do not know what is the content of methanol present into a sample, and let us assume it is X milligram per ml. X milligram per ml of methanol in a sample, right? This 0.012 milligram of methanol in a standard. I hope you are clear on these two equations. They are very, very important, because with the help of these two equations, further I am going to explain you the entire calculation formula. Let me explain you one more time. You analyzed both standard and sample solution, and you found that the response for standard solution is A. So if this response belongs to standard solution, what is the response belongs to? It actually belongs to the concentration of methanol, which is 0.012 mg per ml, because this is the concentration of standard solution. Yeah, and you know the response for sample, that is response B, but that concentration, the content of methanol is unknown to you. Now, as the concentration of standard is expressed in mg per ml, I will say that the response which is belongs to the sample, which is response B in this case, is belongs to a X milligram per ml of methanol. I hope you are now clear. So will I be able to understand the content of methanol in the sample with simple cross multiplication? And let me do that. So the X milligram per ml of methanol in sample is equal to how much? Response B? Yes or no? Response B into 0.012. I will not put the units because the calculation formula looks very dirty. And then divided by A, which is the response from the standard A. I hope you agree with the step number 3. This is the step number 3, right? X milligram of methanol present in a sample is equal to B. Now B stands for the response of this methanol in the sample into 0.012. This 0.012 stands for the concentration of methanol in a standard preparation. And this divided by A, this A stands for the response of the methanol from the standard preparation. I hope you are clear with the step number 3 now, or the calculation formula at the third step. The next important now this is very important step. Can I say 1 ml 1 ml of sample 1 ml of sample will present B into 0.012 divided by A milligram of methanol? Can I say this? Look at here now. What is the concentration of this X milligram of X methanol? It is milligram per ml. Means per ml of the sample actually contain this X milligram of the methanol. And what is the value of the X? The value of X is B into 0.012 divided by A. So I can certainly say, right? I can certainly say that 1 ml of the sample contain B into 0.012 divided by A milligram of the methanol. The unit of this term is milligram. Please focus on to the units. They are very, very important. Now, when I say 1 ml of the sample contains so and so milligram of methanol, but how much? How much is the total sample volume prepared? How much is the total sample volume prepared? If 1 ml contain B into 0.012 divided by A mg of methanol, what should be the content of methanol into a total sample volume? And the total sample volume is 50 ml. Let us go back in the sample preparation step. Step number 2, the 50 ml. So I need to understand now if 1 ml of this resultant sample solution contain B into 0.012 divided by A mg of methanol, right? So this 50 ml will contain how much mg of methanol, right? How much mg of methanol? 1 ml contain B into 0.012 divided by A mg of methanol. Then the 50 mg will contain how much? Will you be able to do that calculation? It is just multiply by 50. So can I say that the 50 into B into 0.012 divided by A, that is the content of methanol in a 50 ml. That is the total volume of the sample dilution. Now this step is very, very important. Now further I am going to connect this step to the actual sample weight. Now this 50 ml methanol content or whatever may be the content observed in the 50 ml is actually coming from where? It is actually coming from the sample weight. So, so, so can I say that whatever content of methanol is actually coming from sample weight? Yes or no? Sample weight. And how much is the sample weight, by the way? The sample weight is nothing but 200 milligram of the sample. So I will build the next equation now. I will build the next equation which is very, very important. I will say 200 milligram of sample contain 50 into B into 0.012 divided by A mg of methanol. Does it make sense now? This last statement, 200 milligram of the sample contains 50 into B into 0.012 divided by A mg of methanol. Now I will put one more step. I would like to understand the content of methanol in 1 kg of sample. Why 1 kg of sample? I will further explain in the next step. And I will say that this 1 kg of sample will contain Y mg of methanol. Will I be able to calculate that? And to keep the unit same, milligram to milligram, this 1 kg will be how much? 1000 gram, right? And if I have to further convert this 1000 gram into a milligram, I will just multiply it by another 1000. So now I got the sample weight in the milligram. Now this is my 1 kg of the sample. So now, what is the Y now? Okay, it is going on the next page. So let me take these two important equations onto the next page for the easy. And then I will say Y milligram of methanol will be how much? Can you able to calculate that? Just do a cross multiplication and you will see 50 into B into 0.012, I will say into 1000 into 1000, or can I replace this into 1000 by 10 raised to 6? Possible? Yeah, I hope you understand this. Otherwise it becomes very, the lengthy equation divided by, okay, so I need to do this. Okay, so divided by A. I hope you understand this y mg of methanol will be y mg of methanol is this 50 into B into 0.012 into 10 raised to 6 divided by A. Now this is the content of methanol present in 1 kg. Yes or no? This is the content of methanol. Content of methanol, or let me put in the next line. So let me copy this content. So this 50 into B into 0.012 into 10 raised to 6 divided by A mg of methanol present in 1 kg of sample. Does it make sense? Because I have calculated for the 1 kg overshare as 200 milligram of having 50 into B into 0.012 by A mg of methanol. This 1 kg will just contain this much. Now can I say that this is nothing but the ppm? Because ppm is nothing but milligram per kg. ppm is nothing but the milligram per kg. So can I say that now my sample contain let me copy this to save time, contain this ppm of methanol, right? My sample contained 50 into B into 0.012 into 10 raised to 6 divided by a ppm of methanol. Can I say that? Certainly, yes. Now I got the calculation formula. So content of methanol, right? I will put over here now the content of methanol, or methanol content in ppm is equal to this 50 into B into 0.012 into 10 raised to 6 divided by A. Okay, so we got to a crude calculation formula now. Let us now go back to the step number 8, which is our last step, which is simplify the calculation formula. The last step is what? Simplify the calculation formula. Let me take the same calculation formula one more time and let me paste over here. The content of methanol in ppm is equal to 50 into B 0.012 into 10 raised to 6 divided by A. Now what I'm going to do, I'm now going to make the calculation formulas which you might have seen into your standard test procedure. So how it is? I'm going to say that I will first take this B. I will take this B first, and I'm going to make it with the red color. Okay, so that I know which figure, which factor I have considered. And what is the B, by the way? Do you remember B? B stands for the response of methanol in the sample. The response of methanol from the sample. Then I will take A. What is A, by the way? A is nothing but the response of methanol from the standard solution. Wow, great. So we got the very first term now. Then I will keep this 0.012 for this time as it is, and I will make it in a red color so to understand this has been considered. Then now what is left? I will take this 50. I will take this 50. So let me put over here and let me go over here. I think we made some mistake, probably over here, if I'm not wrong. And if you can help me out, what is the Y milligram of methanol, by the way? Y should be 50 into B into 0.012 divided by A. But what about this 200 milligram? So this 200 milligram is again going to be a divided by. My apology for error over here. I hope you can understand this now, right? So I will just correct the calculation formulas everywhere. Okay. So please allow me some time to do this, and I hope you understand where I did the mistake. Okay. So let me correct it. A into 200. All right. So let me also put over here now A into 200, and the 200 is how? What is 200? 200 is our sample weight. 200 is our sample weight. So I have taken the 50, which is the dilution of the sample, if you remember. And now I am going to take this 200, which is the sample weight. I'm just rearranging this equation that the way you understand, the way generally the people give in the STP or the standard test procedure. So 200 I keep over here. The 50 ml divided by 200, that is sample weight. What is the next factor now? I would like to take now consider 10 raised to 6. So 50 also taken. So let it turn into a red color. And lastly, I will take 10 raised to 6 over here now. 10 raised to 6. Further, what is this 0.012? This 0.012 is nothing but the concentration of standard in mg per ml. But how this has been made? Let us go back and check the standard preparation. 120 mg of the methanol. The step number 6, defining the standard solution preparation. This is the concentration that I am looking for, 0.012 mg per ml. It is actually prepared by weighing 120 mg of methanol, diluting to 100 ml, and further 1 ml to 100 ml dilution. I will keep the same calculation over here now. Let me copy this entire content and let me paste over here. Now rather than putting this 0.012, what I can put, can I put 120 mg? I will put 120 mg divided by 100. Now this is just the first step. What is the second step? The second step says further 1 ml diluted to 100 ml. I hope you remember the dilution factors. Yes, now we got in the better term. The 50 is the sample dilution, the 200 is the sample weight. Now this 120 mg of the methanol is the amount of methanol taken. But in case if the purity of methanol is only 90%, then will it be 120 milligram of the methanol? It will not. So I did also understand the purity factor, and it will come over here. I will say that the purity of methanol as a P divided by 100. Now this will give me the exact content of methanol after compensating for the potency or the purity of methanol standard. I hope you understand the complete calculation formula design in terms of ppm. So now let us replace the terms, and this is going to be the final calculation formula, by the way. And here we go. What is this 120? This 120 is nothing but the standard weight, standard methanol weight. So I will replace this 120 by standard weight. And then I need to rearrange the calculation equation formula over here. What is the 50? The 50 stands for the sample dilution, and the 200 stand for the what? Sample weight? Sample weight. Great, I got it now. Also very important to understand that this should be in milligram, and hence this should also be in the milligram. So both the weight should be in the same unit, and we will prefer milligram as the unit. We will prefer the milligram as the unit of measurement. Now look at here. We got the complete calculation formula. Allow me some time for the rearrangement. Excellent. So I have done. Now can you see that this is the way you see the calculation formula into your standard test procedure, right? B stands for what? B stands for the response of methanol in the sample. A stands for response of methanol in a standard, and you can also consider the average response, by the way. Then the standard weight means the weight of methanol standard divided by 100. Then 1 ml diluted to 100 ml. You can see the second dilution coming over here. Then the 50 ml is the sample dilution divided by the sample weight. divided by the sample weight. The P stands for the potency for methanol standard divided by 100 into 10 raised to 6. So this is the way you can decide the standard preparation, right? You can also understand how the calculation formula gets derived. I hope you must have now understood the entire process of defining the standard preparation until defining the calculation formula. And you can use this particular procedure for defining the standard concentration for related substances, defining the calculation formula for the related substances also. Thank you so much.